Hello everyone, welcome to the class ECE341, the probability and the random process course. Today we will study the counting problem. The counting problem is things like you have some letters or something, you combine them to form some words. Then how many different kind of words can you have? Of course, you need some restriction. For example, you have you just use A, B, C, D, 4 letters, and suppose the length of the word no more than 5 letters. Then how many different words can you have? The most common used one actually it is a word combined by 2 letters, 0 and 1. 2 numbers actually. You use 0 and 1 to combine them. Now how many words can you have? This is kind of a binary code, right? How many different kind of binary code can you have? Yeah, so this kind of problem, we will try to solve this kind of problem. Alright? This is a ECE341, the counting method. Counting method. We have a basic thing like a fundamental principle. Fundamental. I give this firstly. We use this a lot. Fundamental principle of counting. Suppose we do a experiment. We have we call it a sub-experiment. We have 2 sub-experiment. You do 2 times. The thing we have 26 letters. We pick any letter from these 26. We have 1 letter, right? This is one sub-experiment. Now we need to pick 2 letters. So then we have 2 sub-experiment, right? And combine together as a whole experiment. So we call if we do a experiment has 2 sub-experiment sub-experiment. A and B. A has suppose he has M possible result, and the B has N possible result. Suppose A and B, these 2, they are independent. And the A and B combined together is a whole experiment. Then the whole experiment doesn't matter independent or not. Even they are related, the amount of result will be same. The probability might be different, right? So it doesn't matter whether they are independent. Then the whole experiment will have M times N possible result. So this is a fundamental principle to take account. Example, we consider binary code with 2-bit. Yeah, just 2-bit. So we have 0, 0, 0, 1, 1, 0, 0, 0, right? So that means the whole amount, the sample space, will be 4. And each bit is 1, 1. 0001 1011. We have 4 different. And the first bit 0 or 1, right? Second bit is also 0 or 1. So the thing like this is A, this is B. Then A we have 0 or 1. B we have 0 or 1. Then combined they have 0 0 0 1 1 0 and 1 1. So here the amount is 2. A has amount 2. B also amount is 2. And all of these, this is a total is 4. Amount is 4, right? 2 times 2. 2 times 2. Yeah. So A has totally 2 possible. B has totally 2 possible. Then we have altogether we have 4 possible. So the things like that. And this one we can apply to more than 2 result, right? 2 sub-experiment. If you have 3, like we consider the binary code with 3-bit. Then we consider the sub-experiment A is 1-bit, and the B the other 2-bit. So the A we have 2 possible, 0 or 1, and the B we just studied, right? We know we have 4 possible. Okay, the previous this first example, 2-bit totally we have 4 possible results. Okay, then combine totally the amount will be 2 times 4 equal to A. So here you can think like we combine the totally, you think it's 3 sub experiment. You combine 2 together firstly. These 2 forms one a little bit larger, but it's still sub experiment. And these sub experiment give you 4 possible results. And then the overall, the total experiment combined by A and B, so 2 times 4. You can also consider these, the whole amount is 2 times 2 times 2. It's combined of 3 sub-experiments. Each has 2 possible results. Okay. And in general, if you have like you have a list of sub-experiments, each experiment has count of has some possible result. Then you times all of them together, you can have the whole amount of the possible result. Okay. Then we consider more details. Actually, we have several different kind of the experiment. We still consider the letters, right? Letters, we combine letters, we have word. Then you can think we have 26 letters. We will pick some letters, right, to form a word. Like you pick A. Then after you pick A, the second letter, can you pick A again? Okay, so here we have different, right? If you said every letter you can just use one time, that is one case. You think every letter, every time you can use every letter, then this is another case. This is one consideration. And another thing is, you think like A and B, and B and A, then you change the order. Are they same? If you think they are different, this is one case. You think they are same, this is another case. Right? So we have this one. We suppose in generally pick K letters from N letters. 26 maybe you can consider, we only consider like 4 letters, right? We only use 4 letters to form the word. You can also think you have another system. That language system has more than 26 letters, maybe it has like even 100 letters, right? The n might be large. And the word is combined by letters. You can think you have 2 letters as a word or 10 letters as a word, right? The length might be different. Here we think, okay, we pick K letters to form the letter, form the word. We use K letters, pick K letters from N letters, that give us a word, forms a word. Now how many words can we have? But we have several consideration, 2 considerations. First one, do we have order? So with order, and regardless of what order. Doesn't matter what is order. So like this one, for example, A and B do not equal to B and A because they have different order. And in this case, A and B, you think they are same. B and A, the same thing. Right. So you here without order, regardless order, doesn't matter where you put it. This is one thing. Second thing, each letter you can only use one time, or you can always use it. So we call this as a replacement. We say with replacement. Or without replacement. Okay. You have 26 letters. You pick one out to form your letter, form your word. The next time, when you want to pick a new letter, before you pick new letter, you put the previous one, go back, put it back. So that is replacement, right? You pick one, record, okay, you have A first one, then you put the A back. Next time you still have chance to get that A, right? You put the X, then next time you still have chance to get X because you put it back. And without a replacement, you put some letter. After you put some letter out, then next time you cannot pick the same letter because it already removed. You cannot have it. Right? So these 2 cases are different. Then we check the whole amount. How many possible amount? I put it here. Look at here, the first case. This is the most simple case. We have K letters from N. So and we consider order. So the first is first, the second is second, right? They are different. Okay, so for first one, you have N choice. You can pick N letters, right? And the second one, you still have N choice. So totally, you have K times, right? K letters. Every letter you have N choice. So totally it is N to the K. So whole amount is N to the K. This is a very big number. And this is the case with replacement. And if without the replacement, you have the first number, the first letter you have N choice. Second one is N minus 1, right? Because you already remove one letter. So second time you can only have N minus 1 choice. And the third one will be same number until N minus, we need to take a K, right? So the last one, we have N minus K plus 1 choice. Plus 1, okay, it is 1. We can write this as N factorial over K factorial. Am I good? Oh, not K. I'm sorry, not K. Total length is K, so N minus K. N minus K, right? N minus K. N factorial is 1 times 2 times 3 times until N. and n minus k factorial is 1 times 2 times 3 until n minus k. When you divide it, you will cancel the first n minus k element and left this side n terms, right? N terms. I need these n terms. Yeah. Okay, it is this one. Alright, so this is a case without replacement. Alright, we check here. This part. This part, we still similar with this case, but regardless the order. So different order, we think they are same thing. Okay, so there will be this number n times n minus 1 times n minus k plus 1. I still have these k numbers times them together, but I need to divide it by how many different orders, right? Divided by a number. This number, okay, I will say k letters, because here's without replacement, different. They are different, right? In different order. Then how many different order? How many different order? How many different order? You can think this is thing like, for example, A, B, C. In different order, I have A, C, B. Right? I put A here, then B, C, or I put A here is C, B. I put A here, then B, C, and A here, C, B. Right? This is an example. So totally, I have 1, 2, 3, 4, 5, 6. I have 6. I have 6 different order, in different order, 3 letters in different order. Now, how to calculate in generally? We check that we have 3 locations, right? 3 position. Each position I can put 1 of it. So in the first place, I have 3 choice. After I put A or B here, then I have second place, I have 2 choice. And the last one, no choice, right? I put like A, B here, the last one must be C. But totally I have A, B, C. This is like this. This is just 6. Yeah. So this one actually equal to K times K minus 1 times 1. It is a K factorial. K factorial. So okay. So this one is K factorial. Yeah. Totally we have so many words, but those with different order but the same letters, we consider they are same thing. So each collection of letters, you use them in different order, you totally have K factorial different orders. You consider all these are same thing, so you need to divide it. Divided this one, this is the whole amount. Alright, okay, so these are basically, we have these 3 cases. And this one, oh, this is too difficult, too hard to do it. So in this course we do not discuss it. Alright, yeah, we have these 3, and we have some notations for this. This one actually we can write in this way. The numerator is n factorial divided by n minus k factorial, right? It is this one. And divided by another k factorial. It's writing this way. And we have a notation. It is a let me see. It's n choose k. N choose k. Or c. N choose k. Yeah, we use this notation or this notation to denote this number. And this one, we also have a notation. This notation is n is also n choose k, but in different case, right? N choose k without the replacement and consider the order. So regarding the order, We call this the permutation. This is a combination. It's a combination. Combination. And this is a permutation. Permutation. Alright. Yeah. Permutation. So permutation notation is this, and the number is this one. And the combination notation is this or this, and the number is this one. Okay. Yeah, basically for the counting method, just like this. We have 3 different cases, and in each case we can have the whole amount. And also, of course, we need this fundamental principle. If the whole thing can be divided as some sub-experiment, then you need to multiply them together for the whole amount. Yeah. Let's consider an example. Example 1. We consider the binary code. Right? Binary code. And we suppose the length is 8. Yeah, this is a common used code. We call this is a byte, right? B-Y-T, byte. Byte. 1 byte is 8-bit. 8-bit. So it is a binary code means 0 or 1 sequence, right? Sequence. The length is 8. So I have 8-bit. 8-bit, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, and each will be 0 or 1. Each you put 0 or 1, and or each bit you put 0 or 1. Then I have some questions. Like first one. Now how many possible code? Binary code with length 8. How many possible code totally? Then that will be easy, right? We have 8 locations. Each location I have 2 possible, and 2 times 2 times 2. That is 2 to the 8th. 2 to the 8th. This is the case just like this case. We consider different order as different, and with replacement. That means every bit you can use 0 or 1. You can use both, no matter whether other bit already use it. Right? And the first bit you can use 0, and the second bit you can still use 0. Right? So with replacement and with order, different order, we think they are different. Then we have this number, n to the k. Now n is 2. Right? N is 2. I pick k letters from 2 letters. Right? Yeah. So n is 2. Totally we have k times. So n to the k. Now it's 2 to the 8. 2 to the 8. There will be, what it is? 256, right? 256. Right. And the second we can consider, for example, we want check the codes. The amount of the codes, I suppose, like 3. I want the codes with just 3 zeros. Yeah, some 0, some 1. I suppose totally we have 3 of them are zeros. Then what is this? How to choose it? Any idea? Think about it. 8 location. Each location will be 0 or 1. I will pick 3 from all these locations. Like for example, you put this 3, you put 0 here, and the rest you need to put 1. So here's what you pick: these 3 of the location for your zeros. Then that is one code, right? You pick different 3 location, there will be another word. So you pick 3 from that 8, give you 1 choice. The total choice, that is pick 3 location out of 8 for zeros, and the other 8 location, 8-bit, another 8-bit are ones, right? Things like that. So the whole amount were equal to, you pick 3 from 8. Pick 3 from 8. And here, you do not need to consider order, because you pick 3, like pick any 3 from this 8, and no matter which one is from which one is in the first, which one in the second, all of these 3 you will put 0 in, right? So you do not need, regardless the order. So we pick 3 from 8, and this will be, then we do the calculation, right? This is a times 7 times 6 over 3 times 2 times 1. Yeah, I found it here. We pick 3, pick k from n, right? Pick k out of n. Then numerator we have k terms. Denominator also k terms, right? Pick k from n. Now we pick 3 from 8, so that k is 3. So both numerator and denominator, I have 3 terms. Like this one. Okay. I pick k from n. So now it's 3 from 8. So n is 3. N is 8, and I need 3 terms. So in numerator is 8 times 7 times 6, right? One is n. The second one will be a little bit less. Right? Every time you have a less number. So this is 8, then 7, then 6. Right? 8, 7, 6. I need 3. And denominator is 3 factorial. So it's 3 factorial. Okay, I got this one. And then the result will be, okay, 2, 3, and 6 cancel. So it's 7, 8, it's 56. Alright, 56. Okay, this is the second case. And we can consider more, like third case. We consider the code. Yes, still the code with length A. Now, like I want okay, with more than with 2 or more zeros. 2 or more zeros. Then we can calculate this one will equal to the amount of codes with 2 zeros plus the amount of with 3 zeros, right? And amount of 4 zeros. Oh, I have A, totally A, right? Totally A. I have a lot, right? 4 zeros. Amount of, now all of them are zeros. All of 8 zeros. Oh, this is a lot. We can calculate it another way. This is a whole amount. I write this one. The whole amount minus the code with no zeros and the code with 1 zeros. 1 0. Yeah, I need 2 or more zeros, right? So I minus the no zero and the 1 zeros. Okay, this works. The whole amount we already know is this one, is 256. And no zeros, There only one choice, right? All of them they are 1. 1, 1, 1, 1, then no 0. So this is just one possible result. And the second, 1 zeros. 1 zeros. Similar with second, I choose one location from the 8 and put 0 in that location. So here's a minus C. 8 choose 1. So 8 choose 1 is just A. This is A. This is 8 factorial over 1 factorial. It is A. No, it's just A. 8 over 1 factorial. It is 8. So this is a 256 minus 1 minus 8 is minus 9. That over 247. Yeah, 247. So we have 247 words. The binary code. The length is 8, and they contain at least 2 zeros. 2 zeros or more zeros. Yeah. Alright. This is one example, and we can also consider another thing similar with the binary code. Now we consider the letters, the word with word with I think like a 4 with 4 letters from A, B, C, to X, Y, Z, right? 26 letters. So we consider all the words with length 4. Actually, we in the real world, like in English, we do not have all these 4 letters word, right? We only use some of it. Yeah, but here I just consider problem. All the possible combine of these 26 letters with length 4. How many do we have? So similar. First one we consider total word. That will be what? So I have 4 letters. Each letter I have 26 possible. So it is this one. Oh, what it is? A large number. I just keep it. Alright. Yeah, 26, there will be 6, like 600 something, in a square of 600 something. Oh, it's a large number. I just leave it here. And second, we can consider like similar with last problem. I consider the word with like a 2A. Yeah, we 2A, doesn't matter, capital or lowercase, 2A's, with 2A's. Now what will be the number of these? The number of the words with 2A's. So same thing, we have 4 locations, right? We have 4 locations. Each location I will put one of these 26 letters, but 2 of them they are A, and the other 2 are different. They are not A, right? I have exactly 2 A's. So the amount is we choose 2 locations from these 4 locations, and they are for A's. And I have another 2 locations, right? I pick 2 for A, the other for others, right? If I use 2 for A, the other 2 will be others. I have 25 letters. Each one I have 25 choice. So totally 25 square choice. So this will be 4 choose 2. 4 choose 2. That means 4 choose 2. So I need a 2 in the numerator, and denominator is 2 factorial. And times 25 square, that will be 625. This is 6 times 625. That's still a large number. Okay, I leave it here. Yeah, if you want, you can use calculator to find it. Alright. And 3. I can consider, okay, what kind of things we can choose. Like I want to see this, the number of all the words with first letter is like a P. First letter is P, and first letter is P, what it is. Okay, now we have 4 letters. This one is P, so no choice, right? No choice, just P. And the other 3 could be anything. So this will be another 3. Each one is 26. So it is this one. Okay, then I consider first the number of words. I want the last letter is last letter is like R, is R. Then similar thing, right? Similar thing. This is R, and here is any. So this is also 26 to 3, the cube of it. Okay, the number of words that the first is P, first letter is P, and the last is R. Okay, I have 2 fixed, right? Here's a P, here's R, and I don't know what are these. So this will be, I have 2 can be choose. Yeah. Here, can we say like that? The first one is 26, so I have 26. Yeah, first one is a P. I have this choice, and second one is 26. This one, and the contain both is 26 square. I calculate this. What it is? This one according to the amount of words. First is P, or last is R. In this one, actually I want to ask for this. I want the word first is P or last is R. Then how to calculate this? Remember, we have that PA union B, right, equal to PA plus PB, and we need a minus P, A the intersection with B. So we have this one. We have this one. So if you want to calculate this, you need to use this formula. You find the first letter is R, and the last letter, first letter is P, and the last letter is R. Right. First letter is P, last letter is R. You have these 2. You add them together, but you need a minus. Here's a minus the intersection of these 2. Yeah, you got this one. You got this one. All right. Okay, this is one example. What else can we have? Okay, now let's do some MATLAB work. All right. Every file in the computer is a binary code file, right? Binary file, digital file. It is a sequence of binary code, 0 and 1s, right? Sequence of 0 and 1s. Now how to read those 0 and 1s? We can do this work in any kind of programming language, right? Use MATLAB or C, yeah, or Java or what else. And here I just use MATLAB here. Okay, this is a folder 341. Let's show us the files here. Okay, today we added a new one, that is a lecture for, this is a 04s, Monday's class. Okay, let me edit this one. And here we want to read the file. We can choose any file. You see, in this list I have some names in this folder. Okay, I just use this one, birthday, right? This is a previous class we used MATLAB. We added to this file, right? Okay, now let's read this file. So we need to open it. I said F01. This is the name of this is kind of variable indicate to this file. So this is a F open this file, birthday .m. Then by run this line of code, this file will be open. It will be in a status so that we can read or write date from this file. And now let me read it. Suppose result just in A. A is F read F01, and every time I just read one bit 1. You can type help in the command window to see what are these help. Like F read. Yeah, it will show you how to use this F read function. You need to open it and then read it like this, right? You can read it, yeah. And how to read it? You need to give a this is size. We don't need size. We just read the file, the ID of the file, and then the precision. Actually, it's a type of how to read it. I use bit 1. That means just 1 bit. Oh, do we have that? I think that we have that. There's a binary way. These are the these are different data type. So here I just use a binary bit 1. Just read bit 1. So our result will be just some 0 and 1s. So like this A. Now A will be a list of values. Every AI will looks like this. Not exactly equal. It is a list of binary numbers. So some 0, 0, 0, and the last should be 1 or 0. Yeah, so it looks like this. So after we run this line, you will have A. This A, it will contain several bits, and the first few bits they are zeros, and the last will be either 1 or 0. So this 1 or 0 is the date coming from this file. Okay, after read we need to close it. So F close F01. Okay, then the file is closed. We do not need to read it or write it anymore. Then what are these A's? Okay, let me just run it. You can see F5. You need to ask me to save it. Okay. All right. We do not have display here, so nothing happened in the command window. But here you see I have a A, I have an answer, I have a F01, so I have 3 values. F01 is that file, and answer is this command. I have the third line. When I close this file, it will return the value, tell us the close this operation is well done, or there are some errors. So that is the answer. It should be fine. Then what is A? A is the value we read from this file, right? So this is A. The size is 1480. They are double array. So each element in A is a double value. And can I see it? Oh, it's here. Double value. So you see you have 0, -1, -1, -1, 0, 0, 0, and so on. Why it is -1? As I told, The inside A, every AI will be value looks like this. The first few bits, they are 0, and only the last one might be 0, might be 1. And I think I introduced that, right? Usually the first bit, this is a bit, first bit, that is a sign of the number. This bit is 0, that means it is a negative value. So in MATLAB, this A will appears as a negative value. It will be -1 or -0, but negative and positive 0 are just 0. So when you look at them as values, you will see zeros and -1s. Okay, but actually this should be 1. So if you want, you can keep it or change it. So I put a negative here. Then you will see they are just positive 1s. I run again. No, not positive 1s. Okay, positive 1s. Yeah. And okay, let me turn it. Go to E. So okay, now I have A, right? Every A just contain 1 0 or 1, right? And if you want, you can also think. That depends. You can think this A is a list of symbols of the Bernoulli. Bernoulli, am I good? Bernoulli, I think so. Bernoulli experiment. I mean, it's just the result is just 2 values. If you use coin, there will be face and tail. Here we use numbers, so 0 and 1. So it is a list of symbols. You do the experiment, you have a sample. Now you think it's a list of symbols of Bernoulli experiment. We can also think this file contains the symbols of every 8 bit as one symbol, right? That is an experiment. The symbol space will be a sequence of 8 binary numbers. I mean, totally 256 different symbols, right? We just do the similar calculation, right? You have a binary code. If the length is 8, then how many symbols can we have? There will be 2 to the 8, right? So you can also consider this file is combined by the symbols. Each symbol is an 8-bit. Then we can see what it is. Actually, this file is a text file, right? Our earlier code, that is a text file. So each element in this file is naturally it is 8-bit. Now we can see here, we can realize what are those 8-bit. So totally now how many numbers in A? Okay, size of A. I put these, save them in a K and whatever Q equal to these. Alright. Then this one give us K, the size of A. A should be a column vector, and then K divided by 8. This will be totally how many symbols in this file if we think every 8-bit is a symbol. Then let me run over all these symbols from 1 to K over 8. Then every 8, I will pick this A. Every 8, so it's I times 8, right? I times 8. I times 8 to I times 8, but I need to add more values. A, every piece, like the first piece will be run from 1 to 8, right? The first I is 1, so here should be 1, so minus 7, I get a 1, right? And I times 8 is 8, I is 1, so this is 8, right? I times 8 is 8, and I times my 7 is 1, so this is from 1 to 8, right? This is I equal to 1, and all the rest will be similar. Okay, I use this is a column contain 8 values. I call this as like a C equal to this one. and I transfer this to be a number. So this C, I need every element, the first element times 1, second element times 2, third one times 2 to the 4th. I use a vector way to write it. Okay. Yeah, the MATLAB is you can calculate in the matrix way. So here I use C2. C2 is a power of 2. The power, we have several powers. The power run from 0 to 7. Totally we have 8 number, right? Okay, then I times this C2 on C. This result will be the real number related with that 8-bit, but I need a character. I say D equal to the character of this number. This is MATLAB building function. Your related number to a letter. The number, of course, should be a value between 0 to 255. Okay, I have D. D will be a letter. Every I have a D. So I use this way. If I just write as D, then every time when you get a new D, the old D will be covered. Right? You can see it. Now I use DI. So every time I get a character, I save it in DI. The next time I will work on a new I. So the result will be saved in D. D is a vector. Okay, and alright, let me run it. F5. Oh, too many numbers. Where's the numbers coming from? Maybe I need to use different way. I can combine them together. I use a D as just these two numbers times together. The D is a number, and then I use a E. E is the CHAR of D. This one, and this is the E of I. Okay. Function F5. Alright, now it's good. Now I can run here. Lec04M. I just type the name of the function. I can run it. Then I have E, right? It's still in. I guess something wrong here. Sorry. And I. Oh, it appears I run from 1. Why the I occurs? Oh, sorry. I lost the 4. Okay, now I do it. 4. Okay, now it's fine. I have C2, and then I have E. And what are these E? I still can see. Okay, I can display E here. Just type E, the name of E, then I run it. The value of E will display in the command window. Okay, now it's E. E is here. E equal to this one, right? What is E? E contains a sequence of letters, and they are these. Remember this part? These are just the part of that code, right? The birthday.m. How to calculate the probability of 2 more people have same birthday. I still have an arrow. I missed the end. Which part I get wrong? Arrow expected value function or constant. E. That's right. E. Wrong here. Okay, this time is fine. Alright, no warning. Yeah, I forgot to enter here. So after E, I need to put enter. Actually, enter is also a character in the file. Alright. Okay, so you see, you can look at, you can consider this file contains some samples from experiment, and those samples are letters. Then you get result looks like this. Alright. Yeah, if you change You can also change the size, like every 8-bit you think is one piece. You can also think like every 10-bit or 16-bit as one letter, as one pieces. Then you can have different way to read the symbols from the file. Okay. Alright, that's all for today. See you next time. Bye bye.